And here we are. Now, the problem is simple. The figure shows the graph of the derivative f prime of a function f. The very first question we need to address is on what intervals is f increasing or decreasing? So we are given the graph of f prime. This is the slope of the original graph f. Anywhere that it's increasing will be on the positive side of the x-axis. So, f is increasing for the interval -2 to 0 and from x equals 4 to what appears to be infinity. 4 to positive infinity. And f is decreasing for any part of the graph of f prime below the x-axis. So we have from -infinity to -2. And we have two little intervals here that are both underneath the x-axis, so we'll just go from 0 to 4. And that is what the graph f is decreasing. The next question we need to address is for what values of x does f have a local maximum or minimum? So, local max of f where x equals. And this will be for where local maxes are anything where the slope is going positive and then negative. So we look at what is on the positive side, immediately followed by negative side. We can see right here at the origin, there is a maximum because it goes positive to negative. So where x equals 0, where x equals, let's see, we're looking for a positive to a negative. This is all negative, negative to positive. All right, there are no other local maxes. And just in case didn't fully explain here, it's where it goes a positive slope to a negative slope, and what's splitting them is actually a 0 slope, hence why I chose the spot here, because it went from positive to negative and hit a 0 in the middle right here. It's a small little depiction of it. So we have a local max of f where x equals 0, and now we need to find the local minimums of f where x equals, alright, anywhere that's going negative to positive with the 0 spot in the middle. So we have right here f prime equals 0, we have a negative slope leading into a positive slope, so where x equals -2, x equals a negative slope to a positive slope. Nope, nope, nope. Oh, right here at x equals 4. So we have a local minimum of f where x equals -2 and x equals 4. Now the next question, or next, shall we say, task it assigns us, is sketching the graph of f double prime. So what we need to find is what is the graph of f prime doing. So we'll set up another graph here. 5, 6. And stretch this out. Alright. Now I'm just doing this out of personal preference. I enjoy putting my graphs directly above and below each other so I can actually line up the points. So we have -1 here, -2 here, 0, 1, 2, 3. You get the idea. Alright, so we have all of our x value points. So what is the purpose of y equals the second derivative, so f prime, or f double prime of x? So what we need to find out is what is the graph of f prime doing to find concavity. So as you can see here, I'm drawing out these lines at essentially the max and mins of f prime. Maximins of f prime do not, in fact, reflect the maximins of the graph of f, but they do show us where f double prime of x is going to equal 0. So it's going to be 0 at negative 1. There's going to be a 0 slope at 1, 2, 3, and 5. So we know where it's going to hit 0. Now what we need to do is figure out what exactly is happening with f prime. So f prime's slope is coming down towards 0. So it's decreasing to 0. It's not increasing to 0, it is decreasing to 0. That can only lead me to believe one thing. And as we know here, we have a minimum at negative 2. It leads me to believe that it'll look like this as it approaches. And then after this, it will be decreasing. The slope decreasing because it will be approaching a a maximum. So it makes sense for it to go underneath here. So you may be wondering, what exactly does this mean? This means that over here is going to be concave up as it approaches negative 2 all the way to here. At 1, the graph will become concave down, and that is why f double prime is below the x-axis. When it's negative, it is concave down. So it is concave down until 1, where it starts increasing. So we're going to pass through 1 and become positive again. Because that transition point, wherever f prime of x equals 0, when it starts turning the other direction, we know that the concavity has also changed. When the derivative of f prime becomes 0. So we know concavity has changed. It became positive, and then concavity changes again at 2, it becomes concave down. And we know that concavity does not change until 3. And that goes actually pretty far down, so we'll kind of mimic that. Alright. Concave down, and then at 1 it goes concave up. 2, concave down. And then at 3 it becomes concave up, so we'll just here. So at 3 it becomes concave up, and then at 5 is the last spot. We change concavity, becomes negative, and we can see that the slope of it actually is slowly approaching 0. So if I'm not mistaken here, let's see, f prime is positive and approaching 0, which means to be flattening out. Means f double prime of x will also be approaching 0 if I'm not mistaken. Or I could be wrong. But I'm going to draw it like that. This is, the slope of f prime of x is very slowly decreasing to nothing till it hits 0. So just put a slight curve to it, maybe not as extreme as the first drawing. So that's all good and well. So now we have our concavity. So now it asks us to sketch a possible graph of f. No, it says possible graph because we can't actually guarantee the way it's going to look. We don't know what c is, much less what the actual equation is. Where c is, of course, just a constant. And drawing up another graph. Alright. Well, let's start here. What do we have going on? We know that we have a local minimum at -2 and a local minimum at 4. So let's get all of our points down. 1, 2, 3, 4, 5, 6, 7. Okay. There is a local minimum at -2. Well, alright. And we know that due to the concavity graph, it's going to be concave up. Concave up, concave up, concave up. And then, as you can see, as we've passed -1, it becomes concave down. And we have our max at x equals 0. And then it's going to transition concavity. So we're still concave down until we hit 1, at which point we're going to be concave up. And we're concave up, still decreasing. Except at 2, it actually does become transition again to be concave down. And then at 3, it'll be concave up again, because at 4, there's another minimum. Now the slope is becoming positive, so 1, 2, 3, 4, and then at 5, it's going to transition. So we're concave up, concave up, concave up. At 5, we're concave down. And then, let's see, 1, 2, 3, 4, 5. 5, we're concave down, got that. And then let's look at this then. 6. So this is where it's tricky. At 6 and 7, we actually have the slope is becoming less and less positive as it approaches a 0 slope, which we can really only assume means one thing. It's hit probably a horizontal asymptote is my best guess. Because if it's going to approach 0 but never quite hit it, it's most likely a limit. So the slope is approaching 0, but it's not going to ever really quite get there. And we also know that it's still positive because of what direction it's on. And as you can see here from the graph of f double prime, it's going to maintain a concave down formation to it. So this would be just essentially f of x. This is the graph of f of x. And graph of f, either way. We don't know what the variable is. So slide down, show you all what I did there. We have our key points. We have our minimum, our maximum, minimum, maximum. We have our transition from the concave up to concave down at point 2. And we have the minimum at 4. And what I was just explaining about how it's positive but never quite hitting. And it's going to be concave down for the rest of the graph. And all in all, could be a lot worse.